All right, everybody. I hope you are ready and awake and focused today. And if not, go have a cup of coffee and come back because this week is a doozy, boy. This is a famous unit in precal, no matter where you study precal, and it's kind of got a bad reputation. A lot of students think it's painful and very difficult for them. It's what's funny though is some people think it's crazy easy. You just never know what type of person you're going to be. But I want to give you an intro my way so that you won't be as intimidated when you get to class and have to do this with your teacher. Okay. So what we're going to talk about is it's called a trigonometric identity, okay? Now, an identity is fancy talk, okay, for formula. Honestly, trigonometric formulas or definitions, so they all kind of mean the same thing. Formulas, definitions. You can even go as far as to call them theorems or postulates, just like you used to in geometry, but that's all it is. So it's just going to be some formulas. And these formulas are proven, and they are, let me write the word so I don't lose my train of thought, proven formulas used to simplify expressions and solve for unknown angles. And something to keep in mind is pretty much everything that we are going to do today, and really for the whole chapter for that fact, is don't make this harder than it is. You are pretty much just going to be substituting a lot of formulas in and trying to make things disappear. So that's what I'm going to write right here. So this is kind of your approach to most problem. Substitute in formulas, then do normal algebra. Or I almost should not even call it algebra, arithmetic, because it's just going to be subbing in and then seeing if something cancels or seeing if something combines or seeing if something factors. That's kind of the whole point of this unit, is just simplifying things, okay? So what are these formulas going to be? Well, all of them have fancy names, and I'm going to show you the most popular ones today. These formulas right here that you've actually already seen are the reciprocal and the quotient identities. That's what they are famously referred to as. And I know you've already seen them because when we talked about SOHCAHTOA, we talked about how these were reciprocals of each other, and these were reciprocals of each other, and these were reciprocals of each other. So this is just, instead of writing out the formulas like we did last week where we had opposite, adjacent, hypotenuse, or instead of writing out x's and y's and r's, we're writing them with trig words. And just so you know what I'm talking about, somewhere last week we talked about how the tangent of an angle was actually the, we know it's the opposite over the adjacent, but then we wrote next to that that actually turns out to be the y over the x. This is old news, okay? But if you think about it, what did we say on the unit circle y was equal to? Well, y was equal to sine. And what is x equal to? Well, it's equal to cosine. And so what this list of formulas is doing is it's using what we did last week to figure out this part, and then that's what it's writing down. So that's kind of how you can derive every single formula that's on this page. Now, these are the most basic kind that definitely have to be memorized. And I'm going to go so far as to say that in this section, it will take a little longer, but these also need to be memorized. At least these two. It would be nice if you could memorize this one also. These are called the Pythagorean identities. They have that famous name because honestly, I mean, look at them. Something squared plus something squared equals something squared. I mean, it looks like a Pythagorean theorem. And the other thing is that the other thing is that if you go to derive these three, they actually come from doing the Pythagorean theorem on your picture. Now, I'm not going to do that in the video. Your teacher will probably do it. Or if I see you in tutorials, I'll totally show you because it's actually really cool. But for now, it's one of those, this is true, please trust me, and these are three formulas that we're going to use, okay? So let's do an example of how we might actually use these, okay? So one example might be something like you are shown secant of x times the cosecant of x times the tangent of x, you know, times the sine of x. Okay, maybe you're given just some ridiculously long problem and you are asked to simplify. So if that happens to you, then the goal here would be using the formulas that we just looked at above to try to replace this stuff. Now, nobody has a squared. See, nothing is squared, and since nothing is squared, I'm not going to use any of these. Because you only use these when something's got a squared, or maybe if you saw the number 1, you might think about using these, but we don't need that. So go back up to the identities above and plug in what everybody equals. Now, if you look above, secant is 1 over cosine. Okay. Now, when I see a cosine and a sine, yes, there are formulas for those above, but my goal when I simplify is I try to get sines and cosines. Sines and cosines, because that's going to allow things to cancel out. So like these two that are already a sine and a cosine, I'm just going to recopy. Okay. Now, what is tangent? Tangent above is actually the formula sine over cosine. And I realize you had two choices. You could have either plugged in sine over cosine or 1 over cotan. That's another formula, 1 over cotangent. I didn't choose that because of what I wrote right here, okay? I try to get sines and cosines. So notice what we've done. We've just substituted in for some of the trickier things that we see using the formulas above, and now just do what you can. See if anybody cancels, okay? So I already am thinking of putting those over 1, and look right here. Those cancel, okay? Hallelujah. And then I look over here. Does anybody over here cancel? No, nobody over here cancels. And so what you might do with something like this is just do sine times sine and get sine squared. Cosine times 1 is cosine. So that might be an answer. Okay, maybe. Another way of writing it is maybe someone will go, well, crap, since those don't actually combine, I'm just going to go back to what it was before. And they might write it as tan x sine x. That's an acceptable answer. It just depends on your directions, guys. I didn't give you directions, so either one of these is fine. Most of the time your directions will say, write your answer in terms of sine and cosine. And so if they say that, then that's what you want to go with. So this is sort of the idea. All right, let's try another example. Maybe I can find something that actually needs a Pythagorean identity just so we can practice that. Okay. Okay, so here is the point, I guess, of a Pythagorean identity. You might see something like, how should I do this? Okay, I got it. You might be asked to simplify the following. 1 plus tangent x times 1 minus tangent x. Now, here's the dealio. I've had a lot of students that immediately go and plug in sine over cosine, and then they have to do all of this fraction math here, all the fraction math here, then they have to multiply, then they have to simplify. Okay, that will work, but oh my gosh, it is a lot of work. So what I ask my students to do is before you start subbing stuff in, before you get too happy subbing it in, if there's algebra that you notice, do that first. So if you see algebra, do it first, and then if you can plug in, plug in. So in other words, you know, I've got something times something. Well, if those were just variables, y'all wouldn't think about subbing in. Y'all would think about foiling. And so that's what I'm going to do first. Let's FOIL first. And when we do that, we're going to get 1 minus tangent plus tangent. So those are going to go away. And then minus a tangent times a tangent, which is a tangent squared. So rewind and listen to that again if you didn't get it. But I just FOILed it, and this is what it's going to turn out to be. And after you get something like that, then you can start to look above and say, oh, can I do anything with this? You know, what is the goal here? What am I supposed to do? Now, this one is kind of weird because if I look up at my Pythagorean identities up here, okay, this says 1 minus tan squared, and this says 1 plus tan squared. So you cannot just cross that out and put a secant. Like, that doesn't work. These are not the same. Now, if you want to do something to see if there's something possible, then it's perfectly fine to rearrange this given formula any way you want so that you can substitute in. I mean, if you want to, that's fine. In other words, like let's say that you see this 1 and you think, well, I want to plug in something for that 1. Then you need to come up here to this 1 and try to get it by itself so that you can sub something in. So in other words, if I want up here, if I want this 1 to be by itself, I just subtract tangent squared. Okay, and if I do that, then I could come down here to this and I could replace it with all of that. And these are things that you might try at first. You might say, okay, well, I'm using this identity and I just want to see what happens. So if you take this 1 and you replace it with all of that I squiggle marked, and then you've got that. Okay, did that help our cause? Did anything down here cancel? Unfortunately, not. If one of those was a plus and one of those was a minus, then we'd totally get rid of them. But right now, this just turned into this. Now, what do you think is a more simplified answer? This thing that we had right here, or this thing that we have right here? Well, I think this looks way more simplified, and so I would just say, you know what, I tried to make it look better, but when I tried to plug something in to make it look better, it didn't look better. So I would go back to what I stopped at and just underline that. So these are all things that you try, and it's a lot. There's a big learning curve here. There's a lot of trial and error that goes on, and sometimes you like what you do and sometimes you don't, and you cross it off. So that would be how I would answer that question. Another road that you can go down, you know what, I'm not even going to go there because that would make this video an extra 10 minutes long, but I can show you, you know, if you tried to go into sines and cosines on your paper and then you got stuck somewhere, we can talk about that in tutorials if you're doing that with me. But if not, don't worry about it. Just leave it as is. Okay, so let's go on to the next set of identities. Okay, these are called the sum and difference identities. And it's because of just that. Anytime you see two angles, these are angles by the way, two angles that are being added together or subtracted and they are behind a trig function, this is how you have to separate it. Because believe it or not, I mean, you could pick up your calculator if you want to. If I said that the sine of 45 plus 45 was equal to the sine of 45 plus the sine of 45, that is actually a false statement. And you, like I said, you could pick up your calculator and figure it out, because what is 45 plus 45? Well, that's 90. So the sine of 90, if you look at your unit circle or if you do it in the calculator, the sine of 90 is 1. And then if you do this side, that would be the square root of 2 over 2 plus the square root of 2. Okay, these are not equal. And so that's what makes it a false statement. So when you see something, if somebody gives you this and your gut is distribute, distribute, do not distribute. It's false. It doesn't work. And because distributing doesn't work, that's why some fella or chick figured out all these formulas a long time ago, okay? And that's what the whole math world uses to solve them. So I'm going to give you several examples. For a lot of people, these are their favorites, actually. They look complicated, but in the end, people do pretty well with these. Okay, so the first example is like, what if you're asked to do the cosine of, let me do like, oh gosh, I don't know. How about like, hold on, it won't take me that long, I promise. That would be, let me figure this out, and then I'll let you know. Okay, I think I've figured out a couple that we can work with here. Okay, so for the first one, we're going to do the cosine of 75 degrees. Now, I realize that with a calculator, you can just type that in and you can get an answer, and yay, you're done. We're going to try to evaluate this without a calculator, and what your directions would probably say is they would want you to get an exact answer for this. So not a decimal approximation like the calculator does, but an exact answer. So to do that, the idea is that you take this angle and you are responsible for breaking this into two pieces of angles that are on your unit circle. So 75, I mean, you don't want to do like 60 plus 15 because 60 is on the circle, but 15 degrees, that is not one of the angles that you've memorized, okay? So the ones that you have memorized, though, are 30 and 45. So what you could do is take 30 and 45 and just, I mean, those are equivalent, right? And so once you break this up, then you come up here and you look at the formula that it matches. So I've got cosine of something plus something, something plus something. Now I'm going to plug it into this formula right up here. So in this problem, my u is the 30 and my v is the 45. If I'm just doing a direct comparison above, and now you just expand it and like sub all that junk in. So it's going to look like this. It's going to look like the cosine of the first one times the cosine of the second one minus the sine of the first one times the sine of the second one. And what you get to do with this, ladies and gentlemen, is now every single piece of this you can figure out numerically because these are all on the unit circle and you can just look and fill it in. Remember that the cosine just means the x value and the sine just means the y value. So go back and look at your circle. What is the x value at 30 degrees? Well, it's the square root of 3 over 2. What is the x value at 45 degrees? It's the square root of 2 over 2. I'm going to recopy the minus that's in the middle. Go back and look at the y value at 30 degrees and then the y value at 45 degrees. And if you go back and look at the circle, I know I did that pretty quick, but it's because I have them memorized, and you will too. Once you fill all these in, then it becomes, you know, let's math it out. So when I multiply these, it's going to be the square root of 6 over 4 minus the square root of 2 over 4. They already have a common denominator, so you can write them like that. And you can't put those together, right, because they don't have a matching radical, but you can definitely do this. So that's how these things work. Now, if it's something like 7 pi over 12 and that freaks you out a little bit, go ahead and convert to degrees first if you want. That's what I would do. I would convert it to degrees so it's a little easier to think about in your head. So let's see. To convert to degrees, we need to do 180 over pi and multiply those. And so you're going to be doing, let's see, those would disappear. And 12 and 180, let me do 2 and 30. I think that's 210. So it's the sine of 210. Is that right? Did I do that right? Yeah. 210 degrees, okay, which, oh wow, do we really not have to, I must have done that wrong. Oh wait, it's 210 over 2. Sorry, I'll figure it out in a second. Y'all might have already figured it out and you're waiting on me and you're like, okay, 105. Okay, sine of 105. Haha, my bad. So your new problem is the sine of 105 once you convert it. Now do the same thing we did here. Let's find two angles from the unit circle that make 105. You could do subtraction even if you want. How about, I think we have a 135 on our circle. How about 135 minus 30? Wouldn't that make a 105? Yeah. Okay, so both of these are on my circle, so I just chose those. If you wanted to do 60 and 45, that would also work. It really doesn't matter. I wanted to choose one with subtraction so that you could see that it can be done just the same way. So now when I come up here, it's sine of something minus something, so I need to use this formula, sine of something minus something. So it's going to be sine of the first one times the cosine of the second one plus, that is wrong, everybody. That was copied wrong above. This should be a minus, which means this formula, somebody derped it up. This should be a minus. I don't know where I got this formula from, but it's wrong. Okay, sorry. That should be a minus. And then cosine of the first one times sine of the second one. And then it's just like we did over here. You go to your unit circle and you look up everybody's value, okay? So you do that, I'll do that. This one is this one. Cosine of 30 is root 3 over 2. Cosine of 135 is negative root 2 over 2. And sine of 30 is 1/2. So I would probably do it like this. And then I would multiply root 6 over 4 minus negative root 2 over 4. So that would be root 6 plus root 2 over 4. Notice they look the same, very similar, and a lot of times they will. You just have to figure out who's negative and who's positive and how it all goes together. But anyways, that's how it works, okay? All right, so if you're feeling good about life, let's jump down to double angle identities. If not, go try some of the homework problems, maybe rewatch what you've already done, and then come back for this new set of identities. But the double angle, it's kind of on the same principle as what I showed you above. Unfortunately, if you needed like, I don't know, how do I say this? If you needed to double an angle, you really don't just get to find the answer and double it. It has to break into an actual formula. So if somebody asked you to do, well, I mean, I can't really do any notes here. I'm going to have to just show you with an example down here so you know what I'm talking about. So like if, let's say that you were given a picture and that the angle is over here and you don't know the angle, but maybe you know that it's a 3, 4, 5 triangle. Oops. 3, 4, 5 triangle. Okay, if you know all the sides and they give you an angle, and you know, if somebody asks you for the sine of theta, well, we've done that before. That's just the opposite over the hypotenuse. And so you would say 3/5 and you would be done. Well, if somebody says the sine of 2 theta, okay, that doesn't mean that you get to double that and call it 9/10. Oh wait, that would be 6/10. You don't get to just double it and call it 6/10, or you don't get to double it and call it, I guess that would be 6 over 5, sorry, times 2 over 1, so 6/5. These are not equal, not equal. It doesn't work that way. If you see the sine of 2 theta, you have to use this formula that's up here, the sine of 2 times the angle, and you have to break it into that. So it would be 2 sine of the angle, which we don't really know, times cosine of that angle, and that's how you would have to solve it. So you would recopy the 2. Sine of theta, we do know that, we already found that, that's 3/5. And then times cosine of the angle. Well, the cosine is the adjacent over the hypotenuse. And so then we'd multiply all those together. So I'm getting 24 over 25. And that is how you handle a double angle problem. Yay! Okay, so how do we handle another double angle problem? Well, sometimes you might be given information that just forces you to set up the triangle first, but you'd be asked for the same thing. So maybe it says like, if tangent is -5/12, and you are in quadrant 2, find the cosine of 2 theta. Okay, hold on, I gotta clean this up just a little so that you can read it. Sorry, this is not a good video for me. Sorry, guys. Okay, so if the tangent of theta is -5/12 in quadrant 2, find the cosine of 2 theta. So if you're given a problem like this, it just means it requires a little bit of setup on your part first. So we've kind of done them like this before. If not in videos, if you came to tutorials, we've done them. If not, I'll walk you through it. It's not a horrible deal. Okay, go to quadrant 2. And draw yourself a ray. It doesn't really matter where it goes because we don't know where this angle is anyways. So I'm just going to do like this. Woo, okay, great. Now, what we do from here is we need to create our own right triangle, and you always draw your own right triangle down to the x-axis. That's very important. So draw your triangle down to the x, and you're going to slide your theta always into the inside corner. Okay, so draw to the x, your theta goes to the inside, and now we label what we know. So the tangent is -5/12. Well, tangent, guys, is y over x, or opposite over adjacent. So I know that the 5 goes here and the 12 goes here. Now one of these numbers has to be negative because there's a negative right there. Well, you should know this because you're in quadrant 2, so what's negative in quadrant 2? Well, the x is negative in quadrant 2, so I'm going to put a negative on that 12 right there. Now, we don't know the radius or the hypotenuse, so you do need to find that by doing the Pythagorean theorem. 5 squared plus 12 squared equals blank squared, or you already know this is a Pythagorean triple, and the answer is 13. So either use Pythagorean theorem, or you know your triple. Okay, so now what? Now that we know all the sides of the triangle, let's do this. Okay, so what is cosine of 2 theta? Well, if I look above, cosine of 2 theta is that formula right there. It is 1 minus 2 sine squared theta. I just changed their little a to a theta, okay? And there's actually a lot of formulas, and I just picked one of them. If you look above, I don't know if anybody even noticed that, there's 3 formulas above for cosine of 2 theta. You can choose any one of the 3 that you want, and so I just went with the one that I was staring at on bottom, okay? And they all work, so I chose that one, and now I just fill it in. So a 1 is a 1 minus a 2 is a 2. I need to figure this part out, okay? So I need to figure out what is the sine of theta, and then I need to square it. So what is the sine? Well, sine is opposite over hypotenuse, or x over r. We did both of those formulas. So not x, but y, sorry, y over r. So it would be 5/13. And that needs to be the math that I do. So from here, it would just be simplifying this. And that would be 25/169, 1 minus 50/169. So now I stop talking and I'm just mathing it out. What's 169 minus 50? Is that 119? Yikes. So ugly answer, but that is the answer nonetheless. This homework's going to be frustrating. If it's easy for you, don't tell people because they will be very mad at you. They will hate you if you say, oh, this is easy. They really will. So pretend that it's hard for you too. But it's difficult for most. So if that happens, please don't get frustrated. If you have to watch the solution video for almost every problem, that's okay. That's normal. This is a unit, this one unit where I just did all this in one day, it's like a 1 month long unit at school. Not even lying. It's like an entire stinking month where you'll be doing this. So I crammed a lot into one video, so don't feel bad if you're frustrated. But I'm hoping by watching the videos at least and taking a few notes, it'll just make it a little bit easier when you do it in class. Okay, good luck guys. I'll see you on the solutions.